powerfully to tonight's class. My prayer for you is that all these efforts, all these sacrifices will not be in vain. This is the price for success. We have to put in the time, we have to put in the work and ensure that we are perfect. All right. So I want you to stay awake. I want you to stay strong, and I want you to participate in all the questions we'll be solving. Once again, you know that we'll be solving questions on the basis of several topics. So we're not going to just base our question on just one topic. And as I possibly gave you an hint yesterday, we'll be doing polynomials, we'll be doing conic section, we'll be doing binomial expansion, we'll be doing trigonometry. We also will be doing well, when we get there, you will see it. We'll be doing any other thing that comes our way. So guys, stay alert. Please get your pen, get your jotter, and ensure you pay real attention so we can get the best from tonight's class. So we'll be starting from polynomials. And one of the essence of these classes is you'll be reminded of some things you probably have forgotten, or sometimes you'll be exposed to more technical questions that could that you could see in an exam on the basis of the topics you have read already. So the very first aspect is polynomials. Now look at this polynomial. I don't need to remind you of how you recognize a polynomial. We talked about this in one of our classes on polynomials. And just for revision's sake, one of the basics of polynomials is your polynomial will never have a negative power. Of course, this is a polynomial, and this is the question that went with it. So the question said the remainder when f of x is divided by x minus a is the same as that when f of x is divided by x plus 2a. Now, pay attention to the next condition we are given, where a is a non-zero constant. So the question said you should find the value of a. So as usual, I will give you the privilege to solve in about 2 minutes so that at least you can also gain from the ability to interpret questions. So can you go through the question and let's run through it and see how we are supposed to solve this. So we're given a polynomial f of x. We're told the polynomial is 6x squared plus x plus 7. And this was the write-up as regards the polynomial. We're told that the remainder when, of course, the remainder when f of x, that's this polynomial, is divided by x minus a. So you divided this polynomial f of x by x minus a. Now, they said the answer you got when you did that is the same as that when f of x is divided by x plus 2a. Do you understand the word problem in front of us right now? So x minus a was used to divide this polynomial. We got a remainder. Of course, that means x minus a is not a factor. I'm sure you can relate with that. So if x minus a was a factor, your remainder was going to be 0. That means you were not going to have any remainder. That's one of the theories around factors and remainder under polynomial. So x minus a, if it's a factor of this polynomial, the remainder would not exist. It will be perfect. It will have a perfect division. But in this case now, we're told that the remainder when f of x is divided by this, we had the answer as the same when we divided the same polynomial by x plus 2a. All right. Now, they then told us that a is a non-zero constant. I'm sure you understand the meaning of non-zero constant. That means the values for a, whatever value for a, we must always get an answer that is not zero. So if you get 0 as an answer, you cannot write 0 as an answer. So just to point out, if you go on to solve this and you got 0 and something as an answer, if you fix your answer, probably you have a theory question. If you write in 0 as an answer, that will be wrong because you have been told that 0 is a non-zero, that a is a non-zero constant. So we're told to find the values for a. So has anybody gotten the answer yet? Okay, somebody got 1 over 6. Somebody else got 1 over 6. Somebody else got 1 over 6. All right. Now, if you follow through on what we did last in our class on polynomials, we said something. What we said was, if something like x minus a was used to divide a polynomial, according to the remainder theorem, if you fix in x equals to a into the polynomial, what you get when you fix in x equals to a into the polynomial is the remainder. Let me repeat that again. If x minus a was used to divide a polynomial f of x, if you fix in x equals to a into this polynomial, what you get when you fix in x equals to a is your remainder. So that means what this thing was saying in essence is that when I fix in, of course, we have x minus a, and then we also divided it by x plus 2a. So in this case where it was x plus 2a, what we'll be fixing into the polynomial to get our remainder will be x equals to minus 2a. I'm sure you can understand what's going on there. So this means if we fix in x equal to a equals into this polynomial, what we get is the remainder. If we fix in, for this other side, if we fix in x equals to minus 2a into this polynomial, what we get is the remainder. So we can actually now say f, now fixing in the first one, that's when we're dealing with x minus a, when we're divided by x minus a, fixing x equals to a. That means wherever you see x, put in a. All right. That means this is what you're going to get as the remainder. The remainder will be equal to f of a. The same thing goes for this other one. If I fix in our x now as minus 2a, I'm fixing x as minus 2a, that means I will have f into minus 2a. If I divide by this, if I use this to divide a polynomial, this is going to be the remainder. This, whatever I get when I put in x as minus 2a will be the remainder. So, and the question said, the remainder when f of x was divided by x minus a is the same as that when fx is divided by x plus 2a. This essentially means that in this case, since the remainder are the same, since r is equals to r, that means f of a is equals to f of minus 2a. All right. So it's on this basis we're going to use to go on to solve now. So I believe that is clear. So let me leave that there. Please ensure you are taking good notes. Please ensure you are taking good notes. All right. Now that we have established this, so we want to go on now to get our remainder when we used x minus a, and that will be we fixing x equals to a. So fixing x equals to a into this equation, and let's see what we get. So fa will be equals to 6a squared. That's just wherever you see x, you put in a, plus a plus 7. When you fix in minus 2a, that will be obviously 6 minus 2a squared plus minus 2a plus 7. This will be equals to 6 minus 2 squared, that will be 4. Then a squared. Then this will obviously turn to minus because of plus times minus is plus, is minus. All right, so this will give me 24a squared minus 2a plus 7. All right. Now, this means, the meaning of this is that when I used x minus a to divide this polynomial, this was the remainder. What I see here, 6a squared plus a plus 7, that was the remainder. The same thing goes for when I used x plus 2a. This is the remainder here, what we have here, 24a squared minus 2a plus 7. That is the remainder. But we're told that the remainder are the same. That means I'm okay to say 6a squared plus a plus 7 is equals to 24a squared minus 2a plus 7. I'm sure you guys are following. All right. Now, from here, I believe everybody should be able to dissolve this from here, because don't forget the final question was for us to find the value of a. So now that we have gotten this was based on the word problem. The word problem said, remember, when we used x minus a is the same thing as when we used x plus 2a. This is the expression that expresses that. All right. So go on now to try and solve this. Of course, what you need to do is to bring in the a square and the, in short, let's try and let's fix in all the constant value here. That will be 7 minus 7. We're bringing in the 7 here, will be equals to 24a squared minus 6a squared minus 2a minus a. Right? So we have that. Now let's try and finalize that. That will obviously be 0, because 7 minus 7 is 0, will be equals to 24 minus 6, that will be 18. So that will be 18a squared minus 3a. All right. So we have, we can factorize 3a here, because 3a is common to both. That will be 6a minus 3. Sorry, minus 1, because we have brought out 3a equals to 0. From here, we can see that it is okay for us. I'm sure you understand what this means. That this means we can say 3a is equals to 0, and or we can say 6a minus 1 is equals to 0. When 3a was equals to 0, this will, a will be equals to 0 over 3, and 0 over 3 is 0. And then when 6a minus 1 is equals to 0, that means 6a is equals to 1. And that means a will be equals to 1 over 6. Now, this is a very good place to read your question one more time. Now, we were told that a is a non-zero constant. in this case, you must never include a being equals to 0 because we're already told that it's a non-zero constant. So a equals to 0 will not be used. And our final answer will be a equals to 1 over 6. How many of you were able to get this value? A being equals to 1 over 6. All right. Now we want to move quickly to the next question because of time. Please ensure you are taking a very complete note and ensure you are paying attention to the solutions. So we are still on polynomials. We'll be solving another question on polynomials before we go to a different topic. So this question we solved was an application of the remainder theorem. So let's solve another question and let me see how you fare with that. Again, you would have an opportunity to solve before I start to solve. So a cubic function, this is function, by the way, is defined in terms of a positive constant k. And this is what is defined as f of x being equals to, being equivalent to x cubed plus k minus 1 x squared minus k3. And again, your x is based on the element of real numbers. Now, because of time, I don't want to write the whole note, but it is further given that when f of x is divided by x minus 3, the remainder is 18. The remainder is 18. So the first question said you should determine the value of k. Determine the value of k. So can you do that quickly? In the first, let me give you about 2 minutes to understand the question. Anybody with the answer yet? So the second question said find the remainder when fx is divided by 2x minus 5. Quickly, if you're here to click the thumbs up button, make sure you give this video a thumbs up, all right? Okay, I see people giving answers. This looks like a very intelligent class. I love the way answers are pouring rightly. I love that. I really love that. Please, if you're there and you're not participating, please let me get your answers. Make sure you are trying to solve this so that you can make the best use of tonight. So this question said you have a cubic function It was defined in terms of a positive constant k. Note that. Make sure you read your question perfectly. A positive constant k. And this was what it was described as. You can see x cubed and so on and so forth. And x was an element of real numbers. So f of x is divided by x minus 3. So, but x minus 3 wasn't a factor because you had a remainder and the remainder was 18. So we're told to determine the values of k. With what I just explained to you, I told you already that based on remainder theorem states that when something is divided by a polynomial, when you divide a polynomial is divided by something, when you fix in this case now, when you fix in x equals to 3 into this polynomial, that answer, what you get is the remainder. But one good thing now is that they've told you what the remainder was. So you use that to get the value of the unknown that was in the polynomial. So what this means is that in this case, since what you're using to divide is x minus 3, that means we know that when you fix in x equals to 3, so if you put x equals to 3 into f of x, whatever you get is your remainder. That's remainder theorem, all right? When you put in this x minus 3 into f of x, what you get is your remainder. So let's try and put that in. So f of f3, we put in x as 3, so we'll be having 3 cubed plus k minus 1, 3 square minus k cubed. Now, but we're told already that the remainder was 18. That means we can say after fixing in x as 3 into this place, the remainder is 18. So this is that expression. What was said here, this is the expression mathematically. All right, because when you divide x minus 3, when fx is divided by fx minus 3, this is it, and this is the remainder. All right, makes sense. So you try and solve what I just wrote, and if you try and solve it, you will see that 3 cubed is 27, 3 square is 9, so you have 27 plus k minus 1 times 9 minus k cubed equals to 18. I'm sure everybody can flow with what I'm doing. So this will be 27 plus 9 times k will be 9k minus 9 times 1, that will be 9, minus k cubed equals to 18. I'm sure you guys are flowing. So what you can do now is to observe your like terms. Of course, 27 minus 9 will give you 18. So we'll be having 18 plus 9k minus k cubed equals to 18. So obviously, I take this 18 to the other side, I would have 9k minus k cubed equals to 0 because 18 minus 18 will be 0. So I can factorize k outside, and then I will be left with 9 minus k squared equals to 0. So looking at this implies that k is equals to 0, and also 9 minus k squared is equals to 0. I'm sure you understand what we're doing. So k is equals to 0 is going to be out of my answer. The reason is because I was told that in terms of a positive constant, this is not a positive constant, so that's out of it. So we can try and find the other equation, the other expression there. So let me use this side to get the other expression. Okay, so we have 9 minus k squared is equals to 0. So obviously k squared equals to 9. Of course, you understand that you fix this here, this will be k squared and equals to 9. So you take the square root of both sides, we have k being equals to plus or minus 3. Now, we already know that because of this term that was written there in terms of a positive constant, this means minus 3 will never be part of our answer. So the final answer will be k equals to 3. All right. That is the very first question number A. So let's go on and make an attempt for the question number B. Find the remainder when fx is divided by 2x minus 5. What's going to be the remainder when fx, your polynomial function now, what's going to be the remainder when fx is divided by 2x minus 5? Okay, I want to get responses before I try to solve this. So after this question, we'll be moving into conic section. So please ensure you are paying attention and ensure you are participating, ensure you are trying to solve this, because this goes a long way in assisting you in preparations for your exams. Okay, I'm seeing responses. And I'm loving the responses I'm seeing because those answers are looking right. I love it. Please, if you're there, ensure you are sending your responses. I love to see them. Somebody is saying the answer, or some people are saying the answer is 9/8. All right, that looks nice. Let's try and solve together for those that are still struggling to understand it. Now, again, I said this already. When you are dealing with any topic in mathematics, ensure the basics are the most important thing you pay attention to. All these other things will fall in place. So this question number B is also still on the theory of remainders when it comes to polynomials. Look at it. Find the remainder when fx is divided by 2x minus 5. So the way to find the remainder when dealing with a question like this is just to say, go and fix in x, as all you have to do is say, okay, this is what I'm dividing the polynomial by. So for you to know what you're going to fix in as x, just say equate this to 0 and then try to find x. That will be 2x will be equals to 5 and x will be equals to 5/2. So this means this is what I'll be putting into my polynomial. So putting this into my polynomial is what, if I fix this into my polynomial, whatever I get is the remainder. That is remainder theorem. So I have to fix x as 5/2 into this polynomial and I will get my answer. But don't forget, the polynomial we're given doesn't have the value for k, but we have gotten our value of k as 3. So we have to first of all go on to impute our k value. So our f of x, which is our polynomial, will be x cubed plus 3 minus 1 x squared minus 3 cubed. This is the first thing I want to do before even trying to find the remainder. That's what question number B is asking me to do. I want to first go and use my k into my original polynomial. So this will be x cubed plus this will be 2x squared. This will be minus 3 cubed is what? 27. So, all right, this is my polynomial now. So for me to know the remainder when fx is divided by what I have there, I will go on to put x as this. You put x as 5/2. So that will be f 5/2, which will be equals to 5/2 cube plus 2. Of course, wherever you see x, you are putting 5/2 minus 27. All right. So having done this, you need to just go on to solve. Looking at what we have here, the cube of 5 is 125. That will be 125/8 plus, that will be 2, and then that will be 25/4, and that will be minus 27. That will be 125/8 plus 50/4 minus 27. I'm sure you can all relate to what I'm doing. This is just normal arithmetic. And if you go on to solve this, you'll get the final answer of 9/8 as your answer. Okay. So that's basically it. So if you continue solving this, your final answer will be 9/8. And that will be the remainder when fx is divided by 2x minus 5. All right, so let's shift focus to a different question now. Let's try and solve some questions on conic section. Conic section, right? Please ensure your notes is intact and ensure you're paying attention to all the questions. So let's look at the question here. This question is very short. So you have to find the equation of an ellipse that has the foci as 0 plus or minus 2, and it also has its vertices as 0 plus or minus 3. So let me give you some few minutes to solve this. This is conic section. So look through on this, and I would love to get great responses. You have to find, if you know you have an idea of what to do, can you just give me a heads up, let me know you know what you're doing. You know you have the right path towards this answer. Can you please just give me on the feedback? Just let me know in the chat box. You know what to do. Let me see. Is anybody making an attempt? I'm making an attempt. Can you just signify quickly? Why do we have just half the number of people on this live stream that has given this video a thumbs up? You guys should give this video a thumbs up and let's roll together, right? Okay, I can see people. Okay, that's nice. I love that guys are people are okay. So let me get your response. If you know you don't know what to do at all, can you signify also like you don't have you don't know what to do, you want me to solve it for you? Can you give me your response also? This is the Can you still hear me, please? Can you indicate if you can still hear me? I want to solve this question quickly. Okay, so have you gotten an answer to this? Okay. Wait, can you hear me? Somebody said you can hear. Hope you can hear me. Okay. I'm getting some responses around saying it's not sounding. Okay, is it sounding? Is it showing? Is it okay? Okay. All right. I love that. Now, let's do this very quickly. This is a very important question. Please pay attention to it. All right. Now, we have an equation. We are told to find the equation of an ellipse. And the ellipse has the foci. This is the reason why you need to understand the concept around foci very, very much. Now, let me just do a quick revision around foci. Do you remember when I was teaching you something around saying, if you have a foci, the base of your foci will always be around, of course, okay, let me first talk about the center of the circle before talking about the foci. The center of the ellipse, rather, is always HK. Sorry, we are back. A little glitch from my side here. All right. I want us to solve one or two more questions. There was a little glitch from this side, and let's try and solve this. Hopefully, no glitch happens again. So, looking at this question, I told you already that the core of your foci is actually the center. The center is actually the core of everything. Now, look at what we have here. Look at the foci. It's very important you understand how foci